Bismillahirrahmanirrahim. Guys, today we are going for the second lecture, which is the continuation of the uh, vector quantities which I have delivered you last week. Now we will go for a second one, and I think I wish you must have done you must have gone through the first lecture, or and this is the continuation of that lecture. In this lecture we will go for different components of the forces. That actually why we last time we have discussed in the class why we need these forces, why we want to these forces. When we go in a practical life, and you go in a practical life, you will see a lot of forces acting on the components, on the body, even in your daily life. You will see these examples, and if you go in details of that one, then you will come to know that why it's important for you to go for the components of those forces. Basically, any force that's a driving force on which the body is moving is the resultant of a couple of different forces. And here we will go in a detail of that one. What is the rectangular component? If the force is acting on any angle theta from the x-axis, that force have two components. One is x component, one is y component, and you have to draw those forces on x and y components. And for x and y components in the trigonometry, you know that if the angle is with x component, then the f of x of force is f cos theta, while f of y is f sine theta. And similarly, if you want to find the angle, if the forces are given, if you want to find the angle of that one, you can get the angle by using the trigonometry of tan theta, sine theta, cos theta. There are different options. You can go through that. I'm not going in detail of those options. You know very well. And now it's in this slide, you can see it's a Cartesian vector notations. When the force is described with the x and y component, x is denoted by the component I, while the y is denoted by the j. We are not going in the 3D one. While if you want to know the 3D one, 3D is denoted by the component k. Only our constraint is x and y component. Any force of any angle has x and y components. That is a resultant of x and y component, f(x) I plus f(y) j. And similarly, this is explained in detail in all of that, in all that one. And even if we go for a parallelogram law or a head and tail rule, they have to follow all that law. When you have to find the components of the forces, then you have to determine all that law. And similarly, if there are more than one force, you have to find the resultant of the all coplanar forces. First of all, first of all, do you know what's the coplanar forces? The forces which lie on the same plane. If an x and y plane, you lie on x and y plane. If it's an x and z plane, it's all the forces are lying on the same plane, is called the coplanar forces. And the coplanar forces and are concurrent forces, and there are two. And another is a concurrent forces. Concurrent forces is that they're originating from one single point. And the coplanar to concurrent forces lying at a different angle. If we have to find the resultant of all of that one, we will have to resolve those x and y component of each force. And for that one, x and y component, and then for the resultant one, we have to algebraically sum the f of x component of all the forces and the y component of all the forces. And then we know the Pythagoras theorem. Pythagoras theorem lies on the right angle triangle. If they are on x and y component, then it will make a right angle triangle. And for the f of r, the resultant of that one, using the Pythagoras theorem, we have to square root of x component and the square of the x component and the y component and the summation of both of the forces, and then the resultant of the force will give the under root, taking the under root will give the resultant of the forces. This is as mentioned in this one, and similarly you can draw the direction of that resultant force. And these are the some important points as we have discussed before. You can go very easily through those ones. And now we go for a couple of examples. One of the example is this: they determine the x and y component of f of f1 and f2 acting on the boom, showing in the figure. Express each force as a Cartesian vector. As previously discussed, what is a Cartesian vector? Where here we have to find the x and y component of both forces, f1x, f1y. F1x is lying at a 30° to y-axis. And there are a couple of different ways. If you have to find the angle with the x-axis, you can definitely find it, because x and y-axis are at a right angle triangle. And if you go for the x-axis angle, you can minus 90° minus 30°, you can get a 60°. Otherwise, you can do in the similar way as well. You have to draw the free body diagram separately, as mentioned, as drawn before in the below. And here you will find the x component and y component. For the force F1, it clearly shows that it's lying on the second quadrant, so that the x component will be will be negative, while the y component will be positive. And for the F2 forces, it's not given in the triangle. It's not given the angle with x and y component, but it's given with the triangle. You can find the angle from these ones. By finding the angle, you can get the x component and y component of these F2 forces, and then you have to get, these are the Cartesian coordinates F1 and F2 with the forces, and then the resultant will be the summation of F1 and F2 force, F1x plus F2x, F1y plus F2y, and the resultant will be the using the Pythagoras theorem if it's required. And similarly, for the example 2.6, it's also shown that it is force F1 is 600 Newton, F2 is 400 Newton. F1 is angle of 30° with the x-axis, Fy is 45°, the y-axis. And similarly, if you want to find the force F2x, you can get the angle from with the y-axis as well. But even if you don't want to find the angle, you can resolve it on the y-axis by using the trigonometry. F of r is f1x plus f2x. You can very easily find from these one f1x, f2x, and similarly for the f of r is equal to f1x fx square plus f2 plus fy square and under root. And similarly for the angle direction, you can get the tan inverse of f of y or f of x. Similarly, for the Cartesian coordinate, you can get the Cartesian as well. It's already solved in this example. First, you must go through this example before going to the next question. And this way, in this example, it shows that the boom, there are three forces. Previously, we were going for the two forces. Now we have to go for the three forces. For the three forces, you have to similarly, you have to find the F1F, F1F, X, F2X, F3X. And F1y, F2y, F3y. In this example, you can see F1 is lying on the x-axis. This means its y component will be 0. While F2 and F3 are at some angle with the x or y component, y-axis. You will get the F1, F2y, F2, F3y, F2x, F3x, and you will find the resultant and the direction in the similar way as explained before. These examples also show that all the things, and these are the fundamental problems. Or second, you just go through all these problems. These are fundamental problems, and then there is a detailed problem in those one. And all the problems are given, and I wish you can solve this problem. If you feel any difficulty, you have my email, you have my WhatsApp number. You can contact me at any time. And I wish you must you will do a good job, and you will understand what's required from you, and wish you best of luck. Thank you. See you in the next lecture, and feel free if you have any problem, just feel free. If you have any problem regarding my lectures, regarding any of the issues, you can contact me. Thank you. Wish you best of luck. Bye-bye.